announcement. First of all, today is the due date for the extended phase 1. So I think most of the student format team and they submit the title. If you get the email from the GA regarding to your topic, any comment, please address the comment. Okay. So if your topic is too obvious, probably she reject the topic, and also if that is too difficult or too narrow down, so probably she commented. So why don't you address your her comment for the page 1 document? Okay. And also throughout the semester, when you are doing the project A, okay, this project, pretty much there are a lot of revision. Okay, that's the usual. So you don't have to skip on the first requirement. Sometimes some of the query that design in plain English. Okay, some of the students already asked me what is the query. Query is the function that you are going to implement throughout the semester. Okay, and probably it will be database query later. But right now it's just plain English, so you can imagine whatever you want. But some of them are obvious, some of them are possible, but the others are not possible using the database system. At the time you can keep revising. Then whenever you revise it, you need to revise your document also. So in the last step, the page 4 document should include everything that revised one. Okay. So also, I'm not going to allow the individual projects. So if one of the students ask whether the student can do the project individually, that is not acceptable. Just in case the project will be by the 2 students. So GA tried to her best to set up the 3 group by 3, but in case it can be 2. Okay, but there is no difference. So do I consider the project team by 2? No, it's the same as the group by 3. Okay. And in case of, I don't know how many snow days we have throughout the semester. Based on the last year experience, almost at the end of the spring semester we got snow. So in case the snow, it's a simple rule. If UB campus is closed, I'm going to use the Blackboard Collaborate it's at the same time, the 1:30 Tuesday or the Thursday, using so even though I do not announce, so you need to log on the system, then attend the lecture. Otherwise, in case you are stuck on the I-95 or somewhere, so you cannot access, just in case you can use your cell phone or the telephone. It is available, but I don't think that's a good idea, so you don't have to be frustrated. You can download, or you can watch the recorded video. Okay, usually it takes a day to be available on campus, so it's around 200 megabytes. I think the last one is available right now, so you can download the MP4 file. That will be better. So I don't think it's a good idea to connect the online lecture. So I'm not going to check your attendance in case of a snowy day. So you don't have to worry about too much. The safety is the most important one. Okay. So otherwise, even though there are a lot of huge snow, but the campus is open, then I will running my lecture in the classroom. Okay, that's the simple. Just in case if I have a problem because of snow, but the campus is not closed at the time, I will ask the GA to manage the class. Okay, in case both of them, neither of them are available at the time, probably I will think about the other option. Okay, any questions? Okay, then I know this semester I little bit rush it, the database design part. Actually, this course is designed for the advanced database design, which means the prerequisite of this course is the database design, CPSC551. But because of the department situation, so the undergraduate database design is cross-listed with the advanced database design. So usually I spend 60 or 70% of time for the database design part, then the other 30 to 40% for the advanced database design topic. But many of the graduate students complain about, I already took the database courses too easy. So this semester is the first time to cover the database design part before midterm exam. Okay, so that is the reason I in a hurry, and also I don't want to cancel the class. So even the snow day, I try to manage the class to keep, because if I cancel one of the lecture, so it's totally messed up throughout the semester. So which means I need to definitely your help. The help means you can review or the preview or the review before or after class. So it's your responsibility to follow, especially for the undergraduate student. As I said, the most of the undergraduate students are very, very successful at the end of the semester. So their performance is usually better than the graduate students. So I have no doubt that my undergraduate student can follow. So, but that doesn't mean you can automatically get the grade. Okay, so please work hard. Then right now we almost finished the database design, believe it or not. Okay, so what we are doing right now is from the information are everywhere in our daily life or real life. Whether one of you realize there are a bunch of the different variety of information, even the temperature, moisture, or the weather, or the how many students are here. Sometimes it's a very subjective information. I don't feel very good, or that's the information when I see my student, whether they are sleepy or the tired of the snow. So any information, okay, that can be shared with others. Sometimes I can communicate with the other professor that today the student are very tired because of the snow day or something like that. These are the information, but we cannot keep such information in the computer stuff. So you guys are in the computer, the major. So this is our computer stuff. So we can represent the computer in my class. So eventually we are going to use the system, this device, whatever that is. Okay, not like the information that you take a note in the notebook or whatever. So, but we are going to use a computer to do that. So definitely computer has different mechanism to keep such information. Unlike the human being, unlike the me, unlike the you, the computer cannot understand what the Professor Lee is saying or what I can feel over here. That's totally different. Okay. The main different thing is it can understand only binary data, 0 or 1. So basically, the computer can understand on and off binary data. So, but we need to manage the bunch of different information. Because of that, we need data structure. So mostly, when you take any computer science or computer engineering subject, the most of subjects are related to such a data structure. Otherwise, you don't have to take this course. You don't have to major computer science. You can go to the psychology, or you can go to the other, right? So because we are dealing with the computer, our subjects are related to such a data structure. Database course is the same. Mostly, we are dealing with a very large data, okay, from the information. So if we manage the only small amount of the data, as we discussed before, just like your laptop, you can use just a file system. You can use just the application, other application. That's pretty much enough. Sometimes you can use the memory to keep such a data. Okay, so in case we have a very large database, we need something database system. So our first step is kind of getting close from information or human being to the computer. Okay, so we did the first step. First step is what? So logical database modeling or high-level database modeling. What does that mean? The logical database modeling or abstract level database modeling. The high-level database modeling.
The conceptual level?
It's a conceptual level database design, which means we can organize such information. Okay? At that time, we don't have to worry about this, not right now. So, such a conceptual design, high-level database design, or high-level modeling, abstract level modeling, actually, in our daily life, we are using such a technique. Okay? So, if you go to the desktop in my office, it's a bunch of different paper. You don't like that, so if I ask someone else to organize my desktop, somebody will bring such a file, okay? For the file, then keep this is a database report, this is operating system report, this is the data mining report, and step up and file it, okay? Then you can easily, it's very easy to search the specific report, something like that. How can you do that? So probably you will find some common information, right? That these papers are for operating system or database system, right? Similarly, when you have the bunch of the information in your daily life nearby, so what is the data that is meaningful? The information. So I'm interested in the student information. So I'd like to manage such a student information in our database system eventually. That's our goal. So first step is organize, okay? Such as student information. How did you do that? So you find the entity. What is the entity? Entity is he is the entity of a student. He is also student entity. He is a student entity. By grouping, I realized that this group of entity can be represented by student name, student ID, address, and major. Definitely. Obviously, he has more information. He's interested in the soccer game, and he has a girlfriend, not only just one, the couple of girlfriend or something like that. We don't need such information. If you believe that it's important to manage my student, you can keep it, okay? Depending on the requirement, it can be various. So, in mind, the definition, or customer asked me to organize such as student information, I decide the student name, student ID, address, and major. These are called attributes. So entity, then by grouping, this is called student entity type. Okay. However, as I said, the entity and entity type can be used interchangeably throughout the semester. But you understand what is entity. Entity is a real thing. His entity, his entity, his entity, but as a student, by group, it's a student entity that can be described by attribute, group of attribute. Among that attribute, we can find key attribute. What is a key attribute? So I can realize his ID is 111. So if I call his ID, then he can raise his hand. So I can identify specific entity. At the time, that attribute is called the key attribute. Everybody know right now, even though you don't take this course, you realize the key may be very important to find something, right? So student ID is better than student name. Also, student name is better than student address to identify someone. So in database, that's also very, very important. You will realize later. It's a slightly different the definition, but it's mostly quite similar. So key attribute, such a key of the entity. So you can underline. Can you remember that? So using the diagram, ER diagram, you can underline that. So using that key attribute, you can find the information very, very easily, very, very quickly. How many key attributes? Sometimes no key attribute. Sometimes one, sometimes two, it doesn't matter. However, in database later, each database object, which is called the table later, or relation, we will talk about what is a relation today. So in this database concept, we have only one. Okay? If there is no key, that's not a database table. If there is more than 1, 2, 3, we need to select just one. Some of them already heard about primary key. That is the reason it's called a primary. Among the key, we select one as a primary. Okay, we will see later details about the primary key. That is the first step, entity. We can identify the entity. Similarly, we identify the relationship. So I have the student entity type. I have the instructor the entity type. Then we realize student takes instructor teach the student. Okay, I'm teaching him, I'm teaching him, I'm teaching her, I'm teaching student. So similarly, we can find there's something relationship type, that is the teach. Okay, then teach relationship also may have the attribute. However, teach relationship is a little bit different from the entity. That can be classified as the one-to-one, one-to-many, many-to-many relationship, as you learned in your first exercise lab. Okay, so there are 3 different relationship. Okay, then sometimes you may not have the key attribute. At the time, we call such an attribute as a weak entity. Then using identifying relationship, we can make the weak entity to the strong regular entity type. These are just the everything of the ER modeling. So that is one of the benefit of using ER model. ER modeling is easy and very, very straightforward. It is not only for such a database modeling, it can be used for the software engineering, it can be used for the other application design, even that can be used for the daily life. If you want to organize your method, the room or the dormitory, you can use such a ER modeling. Really. Okay, then ER modeling, one of the problem of the ER modeling is it simple but not flexible. Because of that, it's not very flexible. It cannot cover, it cannot describe all entire our daily life, real life. So one of the example is super and subclasses. Like so for example, I define the person entity at UB. So for the university management system, person. How many different types of person? So many. So student, professor, staff, administrator. All of them are person, but so different types of person. Can we represent such a specific information in our ER modeling? Sometimes yes, not the create possible. So that is the reason why don't we employ the idea of the class that you know, object-oriented concept. So super and subclasses. One superclass and many subclasses. So sometimes it can be overlap, sometimes a disjoint. Okay? So that is the super and subclasses. That is the enhanced entity relationship. That is discussed the last
As much as inheritance. Okay.
Yes. Then so this is an example of the super and subclasses for employee. So how many entity can you find here? It's just one. It's an employee. Okay, this is employee, this is employee, this is employee. It's actually one entity type here, but it's specialized into 3 subclasses: secretary, technician, and engineer. Okay, it can be viewed as generalization also. How? You identify secretary, you identify technician, you identify the engineer. 3 entity types first. Then you may realize secretary, technician, engineers are common as an employee. So at that time you can define and the employee entity type. This is called the generalization. In our database modeling, it's not a big issue whether generalization or specialization. Okay, that is just a thinking process. However, that generalization and specialization are used throughout the modeling. Sometimes you can start from here, subclass, then generalize. Sometimes the specialize from the common information to this one. For example, in this case, the secretary automatically inherit all the information about the superclass, like the name, social security number, birthday, address, job type. So obviously, social security number is the key of the all of this. This time you can see something letter D, circle D, that means disjoint. Disjoint means employee cannot be both secretary and technician, either of them. Okay? So one employee can be either secretary or technician or engineer, that is disjoint. At that time, you can put the something job type to explain details about this. One more thing, is it possible in this example, the employee who is not secretary, who is not technician, who is not engineer? Is it possible? Yes, in this case possible because it is the optional participation. So if you specify employee should be one of these subclass, at the time you can use the double line for participation. Okay? So this is the one more question. I make this one using generalization. Okay? Which means first identify secretary, technician, engineer. So generalize into employee. Does it make sense? Is ER diagram is correct?
Can you please repeat the question?
It should be double line in case of generalization. Why? Because you start from the subclasses. So should be one of these. That's the slightly different thing between specialization and generalization. We will see such an example the maybe next class one more time. Okay, so this is the example of the ER. So another example for overlap, which means a part can be both manufactured part and purchased part. Okay. So this is called the hierarchy. Hierarchy forms a tree, kind of tree structure. Okay, it's a single inheritance. We have one superclass and it's a inheritance. In terms of a subclass, so how many superclass? Only one. This is a hierarchy. Okay. However, we can generalize this hierarchy as a let us allow multiple inheritance, which means this is the employee, and we have the two types of the employee. One is the GA, another one is the regular employee. GA is also student worker. It's a student as well as the employee, which means there might be another superclass that is the student. Then you can have that this kind of inheritance is a multiple inheritance. So in case if you allow such a multiple inheritance, that is called lattice. So for example, this one, engineering manager is inherited by engineer, manager, as well as the salaried employee. So this is the multiple inheritance, which is called lattice. The difference between the hierarchy and lattice is how many? So this is the hierarchy, but this one is the lattice because it has a multiple inheritance. Okay. So this is the another example of the university. Okay. Is it a hierarchy or a lattice? It's a definitely lattice because student assistant is inherited by the employee as well as the student. Okay. So also, how many super and subclasses can you find here?
Only one super?
1, 2, okay, 3, 4, 5. So we have total 5 super and subclasses. That is the benefit. That is the reason to use the ER modeling, which is not possible using only ER modeling. You may try, but it will be very, very complicated to represent such a detailed relationship. This is the ER modeling. We have a couple of more variation of the such a ER modeling. Okay. Another first one is the union type. So union type is first. Why don't we take a look at the example of this? We have owner, okay, and we have a person, bank, and company. So here, which one is the superclass?
Owner.
And which one is the subclass? So here, person, bank, okay, company. They are superclasses. Okay? Superclass, but union then inherit to owner, subclass. So that is different from this one. This one is a multiple inheritance. It's a different super and subclass. Okay? So one super and subclass, another super and subclasses. However, this one is when you inherit is a union. That is the reason it's called the union type. So, but their characteristics are different. So, person is not a bank is not a company. Actually, they are the owner when you purchase the car. Okay. So if you are rich, you can actually purchase a car in cash, right? So you are the only owner, but mostly if you get the finance, so who is the owner? Me and the bank also. Also sometimes you can get another loan or the special program from the manufacturer. Sometimes it can be the 3 different owners. So that to represent that relationship, so we have the owner, but they are different entity actually. Okay, different entity, but they are the owner. So you wanna the group such information using such a union type. It's a one inheritance, but it's from the multiple subclasses. That is called union type. Main problem of the union type is it has a key. They are all different. So later you will, in the conceptual model, it's okay because it's nothing but conceptual design. However, when you implement the database system later, It's a big problem. All of them are owner, but each of them use the different key. So at that time, we will create the later, for example, owner ID, then assign this owner ID to superclass. So this is called the surrogate key, kind of the combining key. Later, we will see the next class is the kind of characteristic. So this is another variation of the ER modeling, not frequently used, but when you see such a the union type, you can understand it's a kind of the grouping for the this one, superclasses and one subclass. Okay. So if we apply all the technique that we have learned, ER or ER and the ER to the university database, it can be like this one. Let's try to understand. So we have the person entity. Person entity has the name, social security number, birthday, sex, and address. We use the composite key and composite attribute for the name and address. That is the reason: first name, middle name, initial, last name, something like that. And also the key of this person is a social security number, which means all subsequent subclasses will have the SSN as the key. So this is a disjoint, which means either faculty or student. It doesn't allow
More than.
the both of them, which means in general it's possible, right?
Right.
So if I register the course as a student, it can be both faculty and student, right? However, in this, the university, they don't allow such an employee as well as a student. So this is a disjoint, so faculty. So, and also from the student, student and graduate student is a subclass. Okay, it's not separate entity, it's a subclass, graduate student. Then faculty and graduate student has a relationship advising and the committee. So many to many and the one to many, like that. Double rectangle is a dual degree, dual or multiple degrees, because it's a multiple the values. Multi-value the attribute. Okay, there's a union type, which means it's inherit to the instructor, researcher. Okay, but from different the entity, actually event they are the same, but if we see only these two, it's a different one, but they are different types of the instructor, researcher. So that is the reason we use the union type. Mostly that union type used for the different types of the entity, like that. We have another entity, that is the department. There are relationships sometimes. It can have many, there might be many relationships between two the entities, the one-to-one chair, and many-to-many belongs to. Okay, so and more. So you cannot now, you should be able to understand when you see such a ER or ER diagram, what's the meaning of such a database. Also, you should be able to eventually, you should be able to make such a ER and ER diagram from the requirement. So if your customer is very nice and well organized, probably your customer will give the description like this one. However, mostly your customer do not provide such a well organized description about the database. Sometimes they just give you a bunch of files, okay? That has only the number. Also, they just explain we need the database, that's it. Then it's your job to understand what the functions are required and what kind of information are here, and that is the reason. Database skill or computer skill is the next one. first you should be domain expertise. You should be expertise on that domain. So for example, there are several interesting project topic, like for example, blood donation system. You should know how it works, how many different types of the donor and how it works, which I do not know. So, but you should be expertise on that system. Also, liquid distributor. So I don't think you are expertise on the liquid. So 23, right? 23 years old, right? But it's not, you don't have to drink to build the system, right? It's okay. So similar, for example, wireless sensor network data analysis, but I'm not an expertise on the wireless data network. So, but you should be expertise. What kind of information you are going to manage in this system, something like that. You can design such a system, starting from the conceptual design, such as ER diagram. Okay. Any question? So the more important thing is you should be domain expertise, then practice. And also, do not, one common mistake is I think this is okay. Yes, in your perspective, this is okay, but it's totally based on the customer requirement. If your customer asks, there's no, the person who are faculty and the student, yes, that's true. That's the Bible, okay? If that is not mentioned in the database, you should communicate with your customer, okay? And also, in the project, the phase one, some of the students just do not realize the importance of the phase one. Phase one is kind of the customer, okay? So some of the group actually design very, very detailed and put all the information, okay? It's like the mega size, the project, which you cannot implement within a semester. So please make the reasonable size. However, that's not a good idea even though I asked the 10 realistic query. So I make only 10 exactly. So 10 does not mean guarantee the A or A plus, okay? That's the minimum, okay? Some of them may not be available, okay? So you need to discard some of them throughout the semester. You may realize, okay? So please, that is a common mistake. So your design, your project is not your knowledge. It should be based on the customer requirement, okay? And then your knowledge is the required to understand and implement. Okay. So I think that pretty much that's the. I'm going to skip the formal definition. Before that, I try to ask the question about the formal. What does that mean, formal? Formal definition. Which means so far we have been discussing informal. Yes, informal definition. So what is a formal in this slide?
Like a definition of something using specific words.
What kind of specific word?
Like
what is a specific in computer science?
Like in terms of data, in terms of.
We talk about the data or not?
For example, let's say that.
What other class are you taking?
Right now?
Yes.
Java 410.
You are senior?
No,
Junior?
sophomore.
Sophomore? Sophomore need to take some other class, Java, and
Yeah.
also what other database?
Database and C++ like that.
C++?
Operating systems.
Operating system?
CS
Yeah.
CS
Are you really sophomore?
Yeah.
What about the last semester then?
Senior project.
Senior, you already did the senior
No,
project?
not. Like last semester.
Oh, last time, previous.
Calculus.
Calculus.
Calculus, yeah.
Why did you take the calculus?
Physics.
You don't know.
Because it's mandatory.
So that is the formula. Okay. So when he said the specific word means mathematical term. So because the computer science is kind of branch of the mathematics, it starts from the mathematics. So, for example, I have a new idea to design something, or I have a new idea to schedule the CPU. So my idea is better than the others. How can you persuade the other? Okay. The best way, if you can prove your idea using the mathematical term, which means equation, as a theorem, you prove it, that is the best way. Okay? Not always it is possible. Sometimes you need to simulate. Also, you need to experiment. You need to implement and show the example. So mine is better than the other. However, when you explain your idea, no matter what types of evaluation you use, you need to use such a formal way. If you just describe I thought a couple of days ago the scheduling algorithm may be better than the others, so I used this one, nobody actually accepts such a thing. So technical paper, such a textbook, use formal definition, which means using mathematical term or equation. You can see the set or the mathematical terminology over here. So it's exactly the same thing that we discussed so far. The only different thing is it uses the mathematical terminology. What is the benefit of the mathematics? Okay? Comparing to the narrative. Mathematics, for example, so in formal way, how can you prove that this one?
Solve it.
You need to
So,
give all the examples,
yeah.
right? Entire your life. May not enough. Okay? However, if we are using the mathematics, you can prove this. You can prove this one, identity. Okay? Instead of giving the example, just a couple of lines, you can prove it. That is true for universe. Even alien, they should agree this, even though the notation may be different, right? That is the mathematics. That is the reason you spend. My daughter keep asking still yesterday, because during the snow day I asked her, why don't you study? Then she complained, why need to study mathematics? Okay? Because it's another language. Okay? Mathematics is another language. And also that's very perfect. There's no description. I don't like when I learn the different language like the English is not my tongue, my mother tongue, definitely. So most difficult part is the descriptive part. So many different ways of it. The red is red, but different ways to describe such a thing. But mathematics is simple. It's just based on and your definition or axiom sometimes. Okay? Then we can prove it. And also it apply, once you prove it, it applies the universe. So that is the formal way. So, however, the problem is difficult first time to understand the concept of it. That is the reason there is an instructor explain that. So I believe you can try to understand, not just from the slide. If you take a look at the textbook, you can see the formal definition of such a ER model and ER model also. So that's the end of the chapter 7 and 8. So mostly we talk about the conceptual design. high-level design of that. Then, as I said, we are just one step forward to the computer. There are a bunch of others. Before we jump to the next step, okay, we need to understand that this one, computer, okay? So if you know that your enemy is always, you can win, right? So you should know about the database itself. Database is also, what is a database?
It's a collection of data.
It's a collection of the data, which means it's not information. Okay, data itself is meaningful information, it's organized information, organized data. So there might be something, data structure,
Stored.
used in the database. We will see such a database model, which is called the database model. Okay, we discussed about what is the model. What is the model? It's a rule. It's a concept. Okay, it's a constraint. Okay, because information you can imagine whatever you want because it's not much restricted. However, database is a very strict rule because the computer cannot understand such a thing. So, for computer to understand such a organized information, we should have such a rule concept that is the database model. ER model is not the database model. It's just a conceptual level model. Okay? It's close to the human being. It's a real life. This database model is close to the computer stuff.
It's a physical level.
Yes, not physical level. So physical level is the, do you remember the three schema architecture?
Right.
So this is the middle one is a conceptual level and internal level,
and then
that
external.
is the physical level.
Okay.
So in between these two, we need something database model. It's close to such a thing. This one, the conceptual level modeling, even not close to this three schema architecture. Okay? So we will learn such a database model. How many different types of the database model in our the computer science? So many.
Yeah.
So many actually. So can we cover all of this in this class? No. We are going to select one of them. That is relational database model. The reason why I select the relational database model is still most popular one and easy to understand. It can be applied to the other. So in this class we will learn such a relational database model. It's a rule, it's a concept, it's a constraint. Okay? Then we can use such a model for the database system later. For example, the Oracle, you probably get the, did you send the email to the student? Oracle account? Not yet? Okay, that's okay. So you will get the information from the GA regarding to your Oracle account soon. Anyway, what is the Oracle? What is the DB2? What is the SQL Server? One MySQL? It's a database software. Okay, when they are when the people developer of the such a DBMS system, they need to select such a database model. Okay, I'm going to use a relational database model. Then it will be relational database management system. If you select object-oriented concept for your database system, it will be object-oriented database management system, ODBMS. So if you select the network database model, it will be network database management system. We will use relational database management system. Okay, relational database model. So you will realize how easy. And also later, after we learn the relational database model, you can see something jump between. So we will next class we will learn how we can map or convert from conceptual model, ER modeling to relational model. Okay, they are quite similar. It's not very complicated. That is one of the reasons why I select ER modeling and relational modeling. That's the why most of the project use such a ER model and the relational database model. Nowadays, it's a little bit changing. Nowadays, because of the size of the data, somebody calls the big data system. Big data to handle the big data, the relational model is not enough. Okay, it's not very flexible. So maybe, who knows, a couple of years later, if the big data system is more popular than the relational database model, I can teach the big data system or the NoSQL database instead of the relational database management system. But I don't think so, because the commercial, the vendor, such as Oracle, IBM, they are too big to be changed.
Right.
They don't want to be risky. Okay? They want to keep their market is good, big enough. So, for example, if you are managing the pizza store, so I have the very well-known famous pizza. So do you want to change the menu?